You have page 419 in front of you?
Yes.
Awesome.
I do know.
So it says the diagram at the right shows parallelogram A, B, C, D, E, F, G, and H. A, B, C, D, E, F, G, and H are midpoints. Why is this not going to, oh, I'll turn it on. So what we need to do is you need to trace it. That's step number one. So if you have a straight edge, that would be nice. We'll make it so we don't have any question about the answers to the questions they asked of us. Anybody going to be gone tomorrow that has not talked to me? Is anybody going to be gone tomorrow who has talked to me? Just you. Okay, just one, right? Sweet. Yeah, that's a little better. So what's the shape, the general shape of what you just traced? Parallelogram. Is that as specific as you can be? It's not a rectangle, is it? Or a square? Is it a rhombus? No? So if you pick it up and you do folding with it, where is there a line of symmetry? All the lines?
Yep.
Hold it up to the light and take a look. Are all the lines of symmetry? Ooh, look at that. That's what I got.
Yeah, that's what I
Okay, how about, that's a diagonal. The diagonal AC. How about the diagonal of BD? No. Oh, looks like a crown or something. Two mountains. Okay. Well, what about FG? Is that a line of symmetry? Is that a line of symmetry?
No.
No. Is there anything left? What about FH? Is that a line of symmetry? Are there any lines of symmetry? No. Why not? So what can we say about this? There are no lines of symmetry. You can say that. What about angles? Are there any congruent angles? Really? Which ones? A and C are congruent? And then B and D? Is that right?
Yeah.
Okay. Nice to have one. I'll just try with this. We'll see what happens. We're going to assume that they're parallel. And then I'm going to assume that these are parallel. So what allows me to mark that in that way? What's a postulate, definition, theorem, or something? It allows me to mark it that way and then give it this name. Or what markings on there allow me to name it parallelogram? Parallel lines. How many sets of parallel lines? Two, being a quadrilateral. So that's the definition of a parallelogram. Okay. So you said that this angle was congruent to that angle? Okay. So how can you do that? How could you justify that they are without just folding it like you can? I mean, you can tear it in half and fold it and slide it around. How do you justify that?
Like, I don't know, when I look at them, I put, like, I think the angle on the outside, it can be considered. I don't know.
When you started talking, you said something about angle on the outside. Did you say something about alternate?
Yeah,
Yeah.
just an alternate.
Alternate exterior, alternate interior? So that's going it's going in the right direction, yeah?
I have a question.
Sure.
So, for parallelogram, can it only have two sets, or could it be like a regular octagon and also be a parallelogram?
Oh, well, parallelogram falls underneath quadrilateral, so then we just have to have two sets, yeah. So we're not gonna go after octagons and do that. So what if we extend this and extend this? Now what can we do to get from maybe this corner, call it angle number 1 up to angle number 2? Can you work your way with 1 or 2 steps to kind of justify that those angles are equal to one another?
Isn't it like alternate interior angles or something?
Could we do alternate interior on this end? Where's the alternate interior to angle number 1?
2.
Way over there. Oh, I don't think so. Because if they're alternate interior, it'd be like this. You have one transversal. And so we have to kind of ignore this end. We gotta do some work here, and then work our way over. So where would be an angle that's congruent to number 1 by alternate interior? Jacob?
The X is the opposite on the line, and then the
Here? So call that number 3, so 1 and 3 are alternate interior and they're congruent? Okay, so now how do we get from 3 to 2? Oh, they're corresponding angles, because these are parallel, corresponding angles of parallel lines. Yeah. So those two are the same. Then we could do the same thing down here, couldn't we? So if we called that number 4, and we went up to there, and eventually got over to number 5, we could also say number 4 and 5 are gonna be congruent. Okay, what about side lengths? So we got angles. We don't have any lines of symmetry. What are side lengths that are going to be congruent or equal to one another? Speak loud, with authority, take a chance. What is it? Which are going to be the same length?
The parallel lines.
The parallel sides.
Yeah.
This will be congruent, and then So those are the things we need to kind of keep in mind with parallelograms as we work with the different problems that they give us. Let me put an example up in front of you. They have a guided example, which is 1 or 2 pages forward, one way down here on the bottom. Okay. So, of course, they give a nice catchy name for it, math. I could have called it band, but I don't know. So they've got math, M-A-T-H. So FT is 5, and MA is 8, and angle MHT is 80 degrees. So we gotta find all these measurements. So how about from F to M? So if you took your what you folded here, would you be able to fold so that B and D are on top of one another? Can you do that? So if you fold it so that B, the vertex of B and the vertex of D lie on top of one another, the angles aren't going to line up. So it'd be like taking this and folding it over. And these sides are not going to line up perfectly, but you can get the tip of the vertex. And then if you do that, then you look at the crease. Where does the crease go through? So what here, maybe I can put this up here. So I take and I fold over so that this vertex D, you can kind of see it sticking right up by vertex B. And then I'm looking at from the midpoint, or this point of intersection of the two diagonals, I'm looking out here to D. If I flip it over, I'm also looking out to B. So from M to D and from M to B, how do those lengths compare? They're equal, yeah, they're the same. So if we look at this segment, MF, that should be congruent to FT. So if, what do they give us? They give us FT is equal to 5. How long is FM going to be?
5.
It's also going to be 5. So the intersection here seems to be the midpoint. So what about H to T? So we've got from H to T. What is that length going to be? Why is it 8?
MA is 8.
Yeah, because MA is 8. Opposite sides are the same length. Okay, so the measure angle MAT.
80.
This should be 80, because angles that are opposite one another, across, they're diagonal to one another, they're going to be of equal measure. What about the measure of HMA? HMA. So we're looking at this one up here. How much?
100.
Say it again.
100.
100. Why?
Because it's a linear pair with the 80.
It's going to be a linear pair because they are,
Supplementary.
if I did this, they are same side interior. Same side of this transversal. They're on the inside of the two parallel lines. Okay. So another theorem here, won't go into this one in great detail, it's relatively straightforward. The distance between two given parallel lines is constant. When we have, if we pick any point along here, and we go perpendicular to one of those sides, this length is gonna be the same, it's gonna be a constant. And then, of course, they have proof on that, but I think that makes sense. If you draw two parallel lines, they're never gonna touch one another, unless you do it on the surface of a sphere, the Earth. Seemingly parallel lines are not parallel, are they? The lines of longitude, they come together at the North Pole and the South Pole. But this is Euclidean geometry, not that geometry. That geometry is more complicated. And then parallelogram symmetry theorem. Every parallelogram has two-fold rotational symmetry. So if we took that parallelogram that we started with here, where's the center of rotation? Yeah, M. It's going to be where these diagonals intersect. So if we just turn this once, twice, we're back to where we started. So that's twofold. How many degrees? 180. So 360 divided by the number of folds. You ready to go? Okay. You bet. Quiz tomorrow. Three-day weekend, then you come back on Wednesday, we do a review, and the end of next week will be a test. Hey, we're not gonna waste time, we're just gonna get her done. Yeah,
Are we
really
done
more
with
than five.
workshop for that?
See, the quiz tomorrow goes through lesson 5. It's a big, long one. So, bring your pencil sharp. Straight edge, protractor, drawing compass.
Do we still have only the amount of time in class?
I'd like to. You know, you guys have got 40 minutes or so of work time right now,
Yeah,
so you're gonna get through a lot of this homework.
but like just thinking about how many proofs we might have to do.
Oh, there's no more than 6 or 8.
6 or 8.
6 or 8.
I'm sure there's not 6 or 8 proofs. Let me look at it, just to double, triple check while you guys are working, but yeah, I think we should be reasonable. I don't have an elevator, but think of it that way. Yeah, there's only 5 questions.
How many of them are proofs?
2.